Hi everyone, I'm Anahita Afshari, a Partner Solution Architect in GPS Americas. Today we're going to delve into the critical role of load balancing in OpenAI, a strategic approach to ensure scalable and efficient application performance under increasing traffic demands. Just to level set, we're going to first discuss the relationship between OpenAI and Azure API management, as it is the preferred method for load balancing best practices. There are a few different ways to load balance with Azure API management, which I'll cover, and then we'll go into a demonstration. So with the rising popularity of OpenAI, it's essential to manage availability for all customers desiring access. OpenAI instances have specific limits on tokens and requests per minute, and many hit these limits when scaling to production. While limits can be increased, a practical workaround is to deploy more OpenAI instances and distribute traffic across them, which is where Azure API Management, or otherwise known as APIM, becomes invaluable. So just to give a brief overview of API management, APIM securely exposes services like the Azure OpenAI API. It consists of an API gateway, management plane, and developer portal, all managed within Azure. The API gateway, otherwise known as the first point of contact for all requests, directs them to the appropriate backend services. It acts as a facade, allowing API providers to abstract API implementations and involve backend architecture without affecting API consumers. APIM ensures consistent configuration of routing, security, throttling, caching, and observability. There are a few techniques that you can use with Azure API management, depending on your business needs and technical capability. The first approach I will discuss is the round-robin approach. OpenAI uses a tokens per minute and requests per minute rate limits, and APIM leverages a static, round-robin, load balancing technique to manage multiple Azure OpenAI service deployments under a single endpoint. It simplifies application code by abstracting the OpenAI service instances and API key management to APIM, using policies and named values from Key Vault. In a simplified flow, the way it works starts with a user making a request to the deployed OpenAI API, and based on the selected Azure OpenAI instance, the API key is retrieved from the Azure Key Vault, and the original requests are forwarded to the selected Azure OpenAI instances, along with the specific API key header. If the request fails, the policy will retry the request with the next OpenAI instance and repeat until the request succeeds or the maximum is reached. So the next approach I'll cover is the throttle-focused approach. So when a service has too many requests, Azure OpenAI will return a retry after response header, indicating the number of seconds that the instance will be unavailable before it starts accepting requests again. This is normally handled by client-side SDKs, which is great if you have a single API endpoint, but gets messy when you have multiple OpenAI endpoints, as you would need to manage the list of URLs in the client side as well. This approach intelligently sends traffic to other OpenAI backends that are not currently throttling. So in the priority order, the highest priority ones are being consumed first while they are not throttling. Once the throttling kicks in, APIM will fall back to lower priority backends, while the highest ones are waiting to recover. This allows no time interval between attempts to call different backends, when lots of other policies have a waiting period. Having APIM wait on the server side is not a best practice because you consume more capacity during this waiting time, so retries would be immediate and to a different endpoint. After finding a healthy backend, APIM will send the request to the chosen backend URL, and if it's successful, the response is passed to the client. If it's another 429 error, then it will read the retry after header to see when it will become available again, and marks that the specific backend URL is throttling and what time it will be healthy again. So then it'll run the logic again to find another non-throttling endpoint. If all the endpoints are throttling, then it will send the customer request to the first backend defined in the list and return its response. So the next thing isn't quite a separate approach, but it's another tool that you can configure with API management. So basically, implementing a circuit breaker pattern protects your backend service from being overwhelmed by excessive requests, preventing cascading failures and enhancing service stability and resiliency. APIM's circuit breaker configuration currently operates on a fixed time, but is being improved for dynamic adjustments to backend availability. The way it works is when the circuit is open, the operation is not performed, so a fallback response is returned instead. When the circuit is closed, the operation is performed as normal. You can configure the circuit breaker property in the backend resource and define rules for what will set off the circuit breaker. So now I'll show you guys a simplified round-robin load balancing approach. Okay, here I am in the Azure portal. Right now, I have an API management service, pretty standard, a standard key vault and a standard managed identity, and then 2 Azure OpenAI instances. One is in UK South and one is in West US to be able to differentiate between each other when I test it out, and it'll make it easy to see. So navigating to one of our instances, we're going to need the keys and endpoints. So you go here to keys and endpoints on the side, and you would copy this endpoint. Right now, it's a link, but it's blurred out for security reasons. Then we can also go back and open our Azure OpenAI Studio, which I've already opened here. And then this is the studio, and we would go navigate to deployments and copy this deployment name, which we will need when we test out our API and load balancing. So now navigating back, let's go into our API management service in resource. So here we have our resource. In backends, we can see that I've already added both of them, the UK South and the West US. But the way you would do it, just click on add, and then you would put that endpoint URL into the backend and then create it. So that's how you would do that. And then we can go now to testing the load balancing to show the round robin approach. So navigating to our APIs, we can go to this OpenAI and now click test. Great. And so this one would be the GPT Turbo 35 Turbo that we have. So GPT 35. And then you need the API version that you use when you set up the API management. And so this is the one that I used. Great. So now we can send. And so here we have it that it went into West US first. So if we send it again, it should now go to UK South. And it did. So this just shows that right now it was first going to the West US to check it out, and there were too many requests. So then it re-navigated to UK South, and now UK South has too many requests. So because I just have the two, it would just go between each other. So if I do it again, it should go back to West US right here. But if you had multiple, it would continue in a kind of circle like a round robin. So that's the demo, and this is just a basic way of load balancing your Azure OpenAI instances with Azure API management.